by Tuesday you can submit, and based on that I can give some bonus points for people who can submit based on number of problems you have solved or you are attempted by next week Tuesday. Because next week Wednesday is your exam, right? Next week Monday also holiday. So next week, so tomorrow we have a class, and then again class will be the next week. Okay. So you can try it out, and then you can see that I will see that how many of you can solve the problem, and based on that I can do something. And the exam syllabus will be up to the tomorrow's class. Okay. Up to tomorrow's class is the exam syllabus. Okay, so we are doing the problem in between. We have star plus class, which was the non-autonomous nonlinear equation, which is xy double prime minus yy prime equals to 0. This is the non-autonomous nonlinear system. And when it comes to non-autonomous, when you remember that the technique is, when you have non-autonomous system, in that case we have to do the equidimensional check, and if it is equidimensional in X, try to see whether you can have this type of terms. If you have this kind of terms, it is easy to transform to equidimensional in X. Okay? So sometimes this type of things will be there. Then you know that if you multiply by x square x, and if you multiply by this, something is going to come. Of course, something may not be there also. So try to see this type of term. This will actually give equidimensional in X. And of course, for our case, definitely you can see that it is x square y double prime and xy prime. Both are actually coming. That's what we can actually do the equidimensional in X. After that, when we do the transformation x equals to b power t, you get the autonomous system. Now the question is, so you see the steps, how I'm approaching a problem, and the same approach you follow for all these problems in your problem set 6. See, point is, we have the first order differential equation and second order. And first order, if it is autonomous, you know how to solve it. If it is linear operator, non-linear operator, definitely you do order reduction. So when you see the differential equation, you see the first, what is the type? Non-autonomous, non-linear, non-homogeneous. This is the worst case. If it is non-autonomous, first step always will be to convert to the autonomous system. Sometimes what actually happens, when the operator is non-autonomous linear, when you convert, it may become autonomous non-linear. But autonomous has to be there. Without autonomous, you cannot solve a problem. When you have autonomous nonlinear system, the next step will be what? Order reduction. Yes, the order reduction. When you do order reduction, it will be easier to, if we are going to easy problem, and then we can see that with the order reduction you may have the linear differential equation, then you can solve it. This is the procedure for an overall set of linear, nonlinear, autonomous, non-autonomous, non-homogeneous system. The same thing was adopted here. So what we actually got here, we got a equals to 0, and which get y equals to constant. Another set we got dA dy equals to y plus 1, and which gave dy by dt equals to y square by 2 plus y plus c0, right? And then what we can get from here, dy by, we can write this as half y plus 1 0 square c0 minus half b. So a lot of calculus things you have to do. Those kind of things what we have done in +2, or sometimes we appeared for the JEE exam or all those things. So those kind of jugglery of the mathematics you have to do. So this entire thing you can write like this, right? Okay? And with that, now I have given a chart of 10 formula. Okay, from the stuff. So that 10 formula you can actually carry for your quiz 2 to apply. That is, of course, I am arranging for you the 2-page A4 size. 2-page means back to back. One sheet back to back you can write. So in that you can write this 10 formula so that for you to remember. So what actually will So we can write another constant 4c1 square equals to c0 2c0 minus 1, and what will be your y? We have the formula in terms of c1 and c0. What we can write? We have done no dy. We have done this kind of problem, right? What is y equals to? C1, I have 4c1 square equals 2c0 minus 1. Am I sure? You will do the calculation, you take the integration, you get in terms of, you get the integration. So, what is the status now? What is that? Anybody can volunteer? Yes. Okay, I will just give the formula. We actually try to see whether we are getting it. 2c1 tan c1 ln x plus c2 minus 1. Another constant c2. Are you getting this kind of thing? Yes or no? Yes? How many yes? 1 or 2. Okay, that's fine. So now, if you want to know how to do, I'll just give some steps. How you got it? I'll just give you a step. From here, we can write 2 dy y plus 1 whole square plus 2 c0 minus 1 equals to dt. This you got from here, right? Yes, I'm just giving a step. How you got it? Only 2 people got it. So what actually happens? We write 2 dy y plus 1 whole square plus 4c1 square equals to dt. Now y plus 1 you write as z, so you can get 2 integral dz divided by z square plus 4c1 square integral dt. Then you can write tan inverse z by 2c1 equals to c1t plus c3 or c2, whatever. C3 I am writing. So we can see that t is nothing but, d3 for t is nothing but x. That's why ln x is coming. Okay? So this dy dt. So with that you can actually write y equals to 2c1 tan c1 ln x plus c3 minus 1, c3 or c2, and the solution is either this or constant. So that's the solution. Okay? So we have to do mathematical Japanese. So at this point you need to know the integration. The integration things, formula, these are all done in the 10 plus 2 level. I remember this kind of things I used to do quite often when I was in my plus 2. So this kind of mathematical Japanese one has to do. Now I will pick up a problem which is equidimensional in y. We have done so much multidimensional in x. This part is clear, this problem is clear how to solve. So this is the first problem you solve, which is non-linear, non-autonomous, homogeneous system. The problem you solve, which is non-linear, non-autonomous, homogeneous differential equation. So if anybody asks, do you know how to solve non-linear differential equation? Answer is yes. And you know the steps, and in the steps you can actually solve it. So let's look at the next problem, which is equidimensional in y. Let's look at the next problem. We now look at equidimensional in y direction. The problem is example problem y double prime y prime square minus y prime by 1 plus x equals to. Can you verify? How to verify? This is y should be substituted by alpha y. And if you write in terms of capital Y, the same equation you get. In that case, you can say this is equidimensional in Y. Can you verify and tell me? So it is what? How to verify? You have to substitute by alpha y. Okay? So it is alpha y. And from here, what you can write? Dy dx is nothing but d. How to write? How to write? I won't tell you how to write. Who can volunteer? Yes, madam? No, I just want the proper way. Forget alpha. What I want to have? I want to have d of capital Y by d is small h. How to get from? I want the formal way. Don't do. You can write d dx of alpha y. You can write d capital Y dx. Similarly, d2y by dx square, which is d dx alpha y d dy by dx. I was trying to skip a step. So d dx, you can write d dx of alpha y. We can write alpha d2y by dx square. Am I correct? So it is alpha capital Y prime plus, you can write capital Y prime because d still is dy by d small x. But for the other case, when you have x equidimensionality, you cannot write the y prime because you have to write dy by d capital X. Okay? So otherwise I can write directly d capital Y by dx plus y prime square is alpha square d capital Y by dx whole square minus alpha capital Y d capital Y dx by 1 plus x equals to 0. So you can see alpha square getting cancelled, and that is equidimensional in Y. In that case, what is the substitution to get the autonomous system? Distinct autonomous system. So what is the thing for autonomous system? How to substitute? Y equals to e to the power u. Substitute y equals to e to the power u. So in that case, what actually happens? In that case, your equation will be transformed. And how to transform? You have y prime, which is d dx of e to the power u, which is e to the power u du dx, and which is nothing but y u prime. Am I correct? Similarly, y double prime. Can you tell me quickly? Y double prime, what's the answer? Y double prime, what's the answer? I want y double prime in terms of u prime, u double prime. Remember that in this case what you had, y prime should not be the right hand side. Right hand side, it will be either in terms of u prime or u double prime. Y will be there, but y prime or y double prime is writing in terms of u. That is the objective. That is the objective here. See, for the x dimensionality, you replace x by t. Okay? Here, in the y dimensionality, equidimensionality, you replace y by u. You replace, so if you want to write y double prime, you have to write in terms of u prime or u double prime. What will happen here if you take the derivative? What will happen if you take the derivative once again? So it will be d dx of ub, right? U dx plus v u dx, two terms should be there. What is your answer? Y into, there is a bracket, u prime whole square plus u double prime. Yep. So now what is your equation? Your differential equation will become, which is u double prime plus 2u prime square minus u prime plus divided by 1 plus x equal to 0. Do you agree or not? Yes? Have you done it? Have you done the calculation? Do you agree with this? Yes or no? Yes, okay. So now, this is the equation. Still, if you look at it, is having the non-autonomous nature already. So what you can do, you can substitute v equals to u prime. Okay. So what do you get from here? If v equals to u prime, it is v prime plus 2v square minus v by 1 plus x equals to 0. So what actually happens? What did I do that? It is still non-autonomous. So next thing is, next week one we have to do auto reduction. That's what I am doing, nothing else you can do. Still this, see that's what equidimension in Y problem is difficult. Equidimension X problem is easy because you know Cauchy type operator, which is very easy to handle. This is a bit difficult. And still you can see non-autonomous is coming. But for the Cauchy type you can see always autonomous things are coming, is very straightforward. In that case nothing can be done. Only thing is you can reduce the order. I have reduced the order. So next is what? Next we can do, so we can see one good news is it is a first order differential equation. First order differential equation we can easily handle because it is you can see that how you can actually handle this. So v prime minus v by 1 plus x equals to minus 2v square. We can write v minus 2v prime minus v prime v to the power minus 1 by 1 plus x equals to minus 2. So what we are doing that? We are dividing this square inside. So it is actually v minus 2v prime v to the power minus 1 by x equals to minus 2. So let v inverse equals to z, and we have z prime is minus v to the power minus 2 v prime. So what actually happens in that case? Minus z prime minus z by 1 plus x equals to minus 2. And we are getting z prime plus z by 1 plus x equals to plus 2. Do you agree or not? Yes? 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 Last bench? Agreed? Okay. Now this is, you can see, this you can solve by integrating factor, right? It is like dy dx plus py equals to q plane. That's the advantage of auto reduction. When we have the second order differential equation, if you reduce, you will get first order, and many times you can see this type of equation will come and which is actually based on your formula, and you can easily solve it. So what is the integrating factor? So this you can solve by integrating factor approach. So if you look at integrating factor, which is 1 plus x, excellent. 1 plus x, integrating factor is 1 plus x. So what actually happens next? How to do it? We have 1 plus x. So this is your dy dx. So dz dx plus py. P is 1 by 1 plus x. Py equals to q is plus 2. Okay? So what you have to do? You have to multiply the integrating factor each term, right? The next one. If you multiply, what you will get? You will get ddx of, what is that? Excellent, 1 plus x into z equals to plus 2. You already multiplied by 1 plus x. Okay? So next is z into 1 plus x equals to 2x plus x squared plus c. Right? Next is you substitute z by z is what? Z is nothing but 1 by v. Okay? So you can write equals to 2x plus x squared plus c. You can write this as c prime plus 1 plus x squared. 1 plus x whole square. You can write v equals to 1 plus x whole square plus c prime. And now v is what? We have seen v equals to u prime, which is du by dx. So du by dx. Du dx equals to 1 plus x by 1 plus x whole square plus c prime, which is equals to du equals to 1 plus x by 1 plus x whole square plus c prime dx. You put integral somewhere. What actually happens? So I will write here again the same term. We can write this as half of differential of 1 plus x whole square plus c prime 1 plus x whole square plus c prime dx. Can you write this as differential of 1 plus x whole square? That will be 2 into 1 plus x, 2 is there to be here, and differential of 1 plus x equal differential of x. 2-3 steps I have jumped here. This kind of things you have done in 10 plus 2, that's why I am doing fast. I don't want to repeat what you have done in your plus 2. This type of things are done. If you are not understanding, please go back to your plus 2 books. Plus 2 books will give you all the answers. This part is clear? What's the next step then? you will get u, right? U means what? U means what we assume? Y equals to u for u. That means ln y equals to half of ln of 1 plus x whole square plus c prime. We can actually write half ln c double. We do that, this kind of thing. Always we take the integration constant based on this term so that we can actually write in y equals to c into something, right? C into e or something. We have done this kind of thing in class 2 calculus. So what we get finally, ln y equals to half of ln c prime double prime 1 plus x whole square plus c prime. Am I correct? That's what I wrote. So that you can actually write in this cubed form. Right? Understood? Amit? Is everything okay so far? Okay. So now what is y? So you can write this as 2 ln y. Yes, what happened? Any confusion here? Half ln. Oh, okay. Just a minute. Am I correct? Yes. Please catch me if I do some mistakes. Okay. So now what you do, you can write this as 2 ln y. Okay. That means what? You can write ln y square. Okay. So you can write y square equals to c double prime 1 plus x whole square plus. So your solution is, you can write this as y square as c1 plus c2 into 1 plus x whole square. That's it. That's the solution. But if you want to have the final solution, you can write this as, that's the final solution. Sometimes what actually happens, you may do some mistakes. Always try to check with the main differential equation, see if it satisfies. Okay? If the solution is wrong, it will not satisfy the main differential equation. Now you saw that how difficult this problem was. Not that difficult. We always went by our procedure. What we said? Non-autonomous system. Making autonomous. How to do? Equidimensional in x, equidimensional in y. If it is equidimensional in y, we put y equals to b equal to u. After putting it, what we saw is it is having non-autonomous nature. Divide by 1 plus x. We cannot do anything. Only things in our hand is we can do auto reduction. We did auto reduction. We found the simple reduction to solve it. So you might see the procedure I have given to you, the mantra I have given to you. You have the weapons. We have to apply the weapons to solve the differential equation. All the weapons actually we have, and that is the we can actually see through the system. Next we do that. It is neither equidimensional in x nor equidimensional in y, which is called as scale band invariant. So we take up one such problem and see how to handle it. So the problem is, which is x square y double prime 3x y prime plus 2y is x to the power minus 4 y to the power minus 3. If we look at this, looks Cauchy-Lagrange, this looks Cauchy-Lagrange, this looks Cauchy-Lagrange. If this term is not there, we can say it is non-homogeneous Cauchy-Lagrange. We can solve by our complementary function complementary what I did in last class. But this guy makes the system problematic. Y to the minus 3. Because always when we have the differential number, you know that should be only dx for non-homogeneous type. So this actually makes the equation. Is this non-homogeneous type? Of course not. This entire is operator. Non-homogeneous operator means L1 equals to Fx. If it is y, this will actually come as operator and it becomes 0. So here no term is there which is free of y. Every term is actually having y. So this is the non-homogeneous, non-autonomous, non-linear type, very complicated, which is not even equidimensional in x, not even equidimensional in y. Understood? These are common mistake. What actually happens? This kind of problem will be given. You say it is non-homogeneous type. It is not good. Because we have y to the power minus 3. Each term is consisting y. So it is. So this is, if you look at the operator, this operator is basically the homogeneous operator, which is non-linear and non-autonomous. Funda is clear? Yes. 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 Any confusion? Doubts? Everything clear? Yes. Okay. So, and this is, I am declaring that this is neither equidimensional index, non-equidimensional y. What is my third option? Third option is replace x by alpha x and y by alpha p capital Y. And in that case, this will give the value of p. And after that, we have to replace this by x to the power p. What is the value of p? How to find the value of p? How to find the value of p? If it is, so if it doesn't work, then you can say I cannot have any of the methods, so this problem cannot be solved automatically. So third we have to apply, which is x is replaced by alpha x, y is replaced by alpha to the power 3y, and in that case, what actually happens in that case? So we have to replace y prime as dy by d capital X, d capital Y by d capital X. So which is dy by dx, which you can write as dy by d capital X by dx, and then we write dy by d capital X, which is alpha, correct? Okay? Dx by dx is alpha, right? Or 1 by alpha? 1 by alpha, yes. And then what you will do that, this part dy by d capital Y, d capital Y by d capital X into 1 by alpha. So dy by d capital Y is how much? D smaller by d capital Y? Alpha to the power p. So totally how much is coming? Alpha to the power p minus 1 dy by dx. Am I correct? Yes. Y double prime is? Y double prime? Can you please tell me quickly what it could be? I don't want to do this thing. Now we're expert how to do all those kind of things. We are really expert. Have the expert is here. What is that? Y double prime will be? Y double prime will be? Y double prime will be how much? Alpha to the power 3 minus 2 d2y by d capital X square. Now plug it in here. You have got everything. You replace x by alpha x. Y double prime as alpha p to the power minus 2 d2y by dx square. 3 alpha into capital X. Y prime is alpha p to the power minus 1 dy dx plus 2 alpha p to the power y equals to alpha capital X to the power minus 4 alpha p to the power p y to the power minus 3. Equate the p. Okay. And see on what value of p you can retain the same form. And that will be the value of p. What is the value of p in that case? After substitution, what value of p will retain? That means what I want finally, x square capital Y, we can write d2y by dx square plus 3 capital X dy dx 2 capital Y capital X minus 4 capital Y to the power minus 3. That's what I want. For particular value of p, if you should get. If you don't get, then there is a problem. Then there is a problem. What is the value of p? What is the value of p? What is the value of p? You substitute and get me the value of p. Pardon? Minus 1 p value. Okay. Anybody else? P is how much? Somebody said p equals to minus 1. Somebody said p equals to minus 1. Is it acceptable? P equals to, second person got p equals to minus 1. Anybody else got p value? Anybody else? Minus 1? How much you got? Third bench, madam. P is minus 1. Okay, correct only. So many people are saying I cannot say no. Okay. So what is the substitution? Y equals to what you will substitute now?
Alpha plus minus 1.
Y equals to?
X square minus 1.
Minus 1 u. So u equals to. That's the substitution. So this method. So this differential equation is solvable, and in that case we have to start the substitution u equals to xy. Okay. So now with u equals to xy, what will happen? U equals to xy, u prime will be xy prime plus y prime. So xy prime is nothing but u prime minus y, and u double prime will be, from here u double prime will be x y double prime plus y prime x prime plus y double prime, right? So how will you get? U double prime will be xy double prime plus 2y prime. So then what you can do, you can actually multiply by x. Am I correct? You got x to y double prime. I am multiplying now by x such that I can get Cauchy-Euler type something. I should at least get some Cauchy-Euler type kind of thing. So you got this stuff. So you got x square y double prime, which is xu double prime minus 2xy prime. Now if you look at, differential equation x square y double prime is there. There is also another reason why I did it, which is now xu double prime minus 2xy prime, and then 3xy prime is 3 into u prime minus y plus 2y, x to the power minus 4, y is how much? U by x to the power minus 3. With this, what you got? Okay. Yeah. What you are finally getting? Simplify. xy prime you can also substitute u prime minus y. If you want, you can do that. I have not done it. xy prime is u prime minus y is already there. So the final expression should not have any y, because you want to have u and x. That's why I said it is like equidimensional in y also have seen. Which one? This one? Yeah, u prime minus y. U prime minus
y prime.
just a minute. U prime minus y prime, you are saying?
Yes, sir.
U equals to xy. U prime is x dy dx plus y. U prime equals to x y prime plus y. And then u prime is nothing but xy prime is right. Okay. Why I have written correctly here? Doesn't matter. I didn't check that step. Okay. What is the final step? Whatever these are a small mistake. It was finally corrected also. But I want to have, because the final expression should not have any y. What is the y? What is the final expression? What's the final expression here? If you want, you can write further step minus 2 xy prime means u prime minus y plus 3u prime minus 3y plus 2y x to the power minus 4 u by x to the power minus 3. If you look at minus 2y plus 2y, and things will get cancelled. You just check it out. The things will get cancelled. X square u double prime minus, no minus will be the final expression. There is no minus. Yeah, x square u double prime plus x cube prime plus u plus equals to 1 by e cube. Anybody else got the answer? So far everything is okay, right? Yeah. From here you have to get removing the y. Y should not be there. You know why should not be there? Because y and u both are independent variables. In that case, how to solve it? Definitely no y will be there, only u will be there. That's the catch. No y will be there, final expression. What's the final expression? Anybody else got it? What's the final expression? Anybody else got it? Yes, sir. X cube double dash. No. How can you x cube double dash? I don't understand. X cube double dash means what? What are we talking? X cube double dash? X cube double dash. X cube double dash. X no, it's not correct. I am surprised that nobody can do this simple mathematics here. Masuda? X square u double prime plus x u prime plus u. Yes, both of you did correctly. Thanks to you. You did the correctly. So you deserve compensations cost. Excellent. Very good. Okay. So now this kind of thing, this very amazing kind of thing you got. This is the Cauchy-Euler type. This is Cauchy-Euler type differential operator. So in that case, what actually we can see that not only Cauchy-Euler type, it is very amazing in the sense if you substitute by x by alpha x, this is equidimensional in x direction. So you got, so now what you did from here after so much exercise, you got equidimensional in x equation. So this is equidimensional. Equidimensional in x, that means you can substitute by x by alpha x, and of course your final equation you have to start with x equals to the power t. If you do that, what you finally get? X equals to the power t. What? Very nice equation you get. If you substitute x equals to the power t, you get a very simple equation. What is that? You get a very simple equation. What is that? In terms of u and t, no x will be there. Now this equidimensional in x we have done it already. Equidimensional in x we have already done it. d2u by dt2 plus equals to, that's it. So simple. This is the homogeneous or non-homogeneous equation. Is it homogeneous differential equation or non-homogeneous differential equation? Because of there is no t term here, everything is having u. It is what equation then? Homogeneous then? It is homogeneous, nonlinear, autonomous. I told three terms of it all the time. Homogeneous, nonlinear, autonomous. Next step will be what? If you don't know the steps, if you don't get the correctly the name, order reduction technique. So I say P equals to du. You know the steps correctly. Next step. So in that case, what's the next step? Your independent variable t will not be there. Rather, you will have what? Your u will become independent variable, right? You have to write in terms of dp du or something. How to write the differential equation? How to write? What will happen? You will tell me the answer. Final form. Tell me the final form. Tell me the final. You are remember that you are replacing d2 by dt2 in the first order derivative. Yep, you are right. P dp du plus u equals to the power minus 3, and what you get? This is, you can get P dp du, which is 1 minus q to the power 3 u cube. You can write P dp, which is 1 minus u to the power 4 u cube du. Next step. Next step. Next step. Now we know the next step. You are solving the almost solving. That's it. Once you come to this step, you are done. You are 90% done. Now you know the problem is solvable. P square by 2, right? Equals to, it is very easy, 1 by u by 3 du minus u du. What is that? P square by 2 equals to, so I will write the step du dt equals to 2c0 u square minus e to the power 4 minus 1 whole to the power half by u. Did you get it? By u. Did you get it? We first got p square by 2, which is u to the power minus 2 by minus 2 minus p square by 2 plus c0, right? Then p square you got multiplied by 2, you got the integration constant multiplied, and then you substitute, and then you take the square root, you get the term. You just do that similar procedure. So that thing I think you can do it by yourself. Then du divided by u du, and then we have 2c0 u square minus e to the power 4 minus 1 to the power half equals to dt, which you can say we can write, I am multiplying to both sides. Okay? Why? Because I will assume here let z equals to u square minus c0, so that dz equals to 2 into du. Why? Because you see this kind of technique already we have done it already, which is c0 square minus 1 minus q square minus c0 whole square whole to the power half equals to 2 dt. We will get this step. I have done so much things here so far. And these kind of things I remember I used to do during my class 2 calculus. I am referring from my class 2 calculus note, remember that. This kind of differential things I have done in my class 2. So this part I have just referred from my class 2 calculus notes, I already reserved. And since I thought, since I have done in class 2, I should do this kind of thing very fast. There is nothing in detail faster than this here. Is everything clear? Do you know? Do you understand this step? How I got it? Yes or no? Yes? Third bench, madam? Do you understand this part? Okay, next step. Next we have given that z is, so u square minus c0 is nothing but the z. So it is c0 square minus 1 minus z square. So you can write this as c0 square minus 1 square root of whole square is nothing but integral dz by a square minus z square. And this kind of things already have discussed the formula. What is the formula? If you apply the formula, what you got? If you apply the formula, what you will get? If you apply the formula, what you will get? No. It will be not better. You just look at the class notes. Look at the class notes. Sin inverse. Z is what? U square minus C0 divided by root of C square minus 1 plus the integration constant C1 equals to 2t. Am I correct? 2t plus C1. So what you get? You get U square minus C0. The square root of C0 square minus 1 plus C1 is sine 2 ln x, because we have assumed x equals to b for t, right? And then you get from here U square equals to C0, the square root of C0 square minus 1 sine 2 ln x minus C1, and then your y is nothing but, what is U? U equals to y, xy, right? U equals to how much? xy. U equals to xy. So it is x square y square, right? So it will be square root. So plus minus 1 by x will be there. Otherwise, all the terms should be under the root, which is sine 2 ln x minus c1 whole to the power half. That is the answer. And you can see that at x equals to 0, y has singularity. And that means what? At x equals to 0, there is no solution. At x equals to this has no solution. So this has got a singularity. This has got a singularity. Understood this problem? So please, you have to practice this. So a lot of things I am referring from calculus to calculus. As I said, in this course, we take first level mathematics I cover, but plus 2 calculus I do not cover. That is your duty. So whenever the plus 2 calculus is coming, I am just doing very fast because already it is covered in plus 2. Okay. Last part of differential equation, which is very easy, which is called as sort of Bernoulli equation. We have seen Bernoulli differential equation. So last part. Last part we will be talking about the Bernoulli, or it is called as Riccati type differential equation. This is called as Riccati type differential equation. And what is Riccati? Is sort of a bit one step ahead of Bernoulli equation. I hope you remember Bernoulli equation. I will cover the Bernoulli equation first, and then we will go to the Riccati type differential equation, which is y prime f naught x plus f1xy plus f2x y square. It is the first order differential equation, you can see that. The first order differential, first order autonomous. No, not autonomous. First order non-autonomous differential equation. Homogeneous. And also, if f0x equals to 0, the equation is Bernoulli type. Right? If f0x equals to 0, this equation is the Bernoulli type. And Bernoulli type equation you can solve it. How to solve it, you know that. Bernoulli type equation you can solve it. How to solve? It is dy dx plus fi plus qy equals to q. That's the Bernoulli equation. What is Bernoulli type equation? Dy dx plus py equals to qy to the power something like that. That is called Bernoulli type. But because of this term, this is not Bernoulli type, because you can say dy dx py qy to the power is there. Because of this fellow is creating problem. This fellow is creating problem. Somehow we have to get rid of this guy. Because of this type of equation is known as the Riccati type differential equation. Because of this type of differential equation known as Riccati type differential equation. Okay. So how to convert Riccati to Bernoulli? You substitute by y equals to y1x plus c. Okay, such that y1 satisfies the first differential equation, such that y1 satisfies this differential equation. Okay, so what will happen? y1 prime plus u prime f0x plus f1x y plus u plus f2x plus into y plus u whole square. Next step, y1 plus u whole square. Sorry, y1 prime, y1, yes, y1 prime plus u prime, which is f0x plus f1x y1 plus f2x y1 square. I am taking it separately. Extra terms are f0x u plus f2x into 2u y1 plus u square Am I correct? Yes, so far? So far everything is correct. I have collected this term, I have collected this term, I have collected the first term. Then what is remaining? f1x into u, f2